Good day, guys. Welcome to GDS Academy. And we are on the continuation of differential calculus. But in our previous class, we discussed the general formula, the product rule, the quotient rule, the chain rule. Sorry, quotient rule was not there. The chain rule and the core rule. But for this class, we'll be discussing quotient, exponential, and logarithmic. And we try as much as possible to make this as quick as possible, and at the same time, you get what we are trying to say. Now, for the first question, okay, before we get to any of the questions, I would like to give you, the formula for it. Now, we have our y is equals to what? U over v. So therefore, our dy dx is equals to what? V du dx minus u dv over dx over v square. Or, let's assume we are using function f of x. Let's say if f of x is equals to what? U over v. Then you can say f of x derivative is equals to what? V dot derivative of u minus u dot derivative of v over what? V square. As you can see, this seems to consume less space. So I'm trying to do whatever I want to do using the whole of these lines. Now let's move into this one. So I'm representing this with the function of x. Therefore, for number one, our u is what? This is our u, and this is our what? V. So our u is equals to x squared plus 3. Our v is equals to x plus 2. Now, our u derivative is what? That will be 2x. Then our v derivative is what? 1. Therefore, we can successfully see that our derivative of this is what? V, what's our v? X plus 2 in bracket. The derivative of u is what? 2x minus our u, which is x squared plus 3 in bracket. Then our derivative of v is what? 1 all over v squared, that is x plus 2 in bracket square. So this is as easy as possible. This becomes 2x squared times 4x. So minus will expand this. This becomes minus. Because if you multiply anything multiplied by 1, it will still give you the exact value back. So we have gotten this. Then minus, this will give us x squared minus 3 over, if you expand this will give us what? X squared plus what? 4x plus what? 4. Now let's settle this out, and that becomes what? X squared plus 4x minus 3 over x squared minus 4x, sorry, plus 4x plus what? 4. This is our what? Derivative. It's as simple as that. We are done with what? Number one. Now, number two. Let me solve it as fast as we can. Now, you can press pause and try it out before I eventually solve this. So, okay, let me now use this for it. So, depending on how you graph quickly, so some they might be used to this, some might be used to this. So now, our u is what? 3x plus 1. Our v is just x squared. So our du, our derivative of this du dx is equals to 3. Our dv dx is equals to what? 2x. Now we can now say that our dy dx over dx is equals to what? V, which is x squared, times du, which is 3, minus u, which is what? Let me put it in bracket, 3x plus 1, times what? dv, and that's what? 2x. Everything all over what? V square. So this is x square, right? Square. Then we can now expand. So this is equals to what? 3x square minus, let's assume this is happens to be a, this will give us what? Minus what? 6x square minus what? 2x all over x to the power of what? 4. So this will give us what? Minus what? 3x square minus 2x over what? X to the power of 4. Now, you can still go ahead and factorize again and divide some things. So this is equals to what? Let's assume x is common. So this equals 3x minus 2 plus 2 over x to the power of 4. So x here cancel. X here, this is 3. So you can now see that our dy over dx is equals to what? Minus what? 3x minus 2 over what? X to the power of 3. That's all for what? Quotient. That's all for what? Quotient. Now, how did we get this? This is what? Minus 1. Remember, this was the initial equation before. So this becomes what? Minus 1 times 3 has to give us minus 3. Minus times plus will still give us minus. Then we have our 2. So that is why it is like that. Now we are done with quotient. Let us move to exponential function, which we'll be managing here for. So that is 3. Now, in most textbooks, they will tell you that the derivative of e to the power of x is still equals to e to the power of x, but there's a reason for that. And the reason is, if you have to find the y dx of this, it will be what? The derivative of the power, or the differentiation of x here is what? 1 times the whole of the expression itself. That is why it is what? It gives us back e to the power of x. That is why we have the derivative of e to the power of x to be e to the power of x. Now, whenever you are now solving something like this, where we have, that was number 4, when we have our y is equals to e to the power of what? X squared plus what? 3. Now, people now get to be confused. So this is what we do. This is what we do. Our dy over dx is equal to, we should find the differentiation of this. Times what? E over what? X squared plus 3 itself. Now, is this getting clear on what we are doing? Now, this will give us what? 2x times what? E to the power of what? X squared plus what? 3. Therefore, you can now see this is 2. This is what? 2x e to the power of what? X squared plus what? 3. This is our final answer. So I can even decide to include something else by saying, okay, let us just quickly do this rough work. If our y is equals to what? E to the power of what? 4x what? Cube. If you have to solve this, that is our dy over dx will be equals to what? What's the derivative of this? That's what? 3 times 4 abi? 12x. Then you reduce this by 1. That's what? 2. Times what? E itself abi? 4x what? Cube. So you can now say that this is what? 12. Sorry. So you can just write it together. E to the power of what? 4x cube. So with this, I'm sure you guys should be able to understand how to find the derivative of an exponential function. Now, for today, we are done with what? Exponential function. I'm moving to what? Logarithmic. Now, we have log what? 6x plus 6x cubed plus 2x squared. Now, you have to solve this using, remember, our y is equals to this. So, if you have to solve this, our dy over dx is equals to, let's assume our u is equals to what? 6x3 plus 2x squared. Remember, there's no power at the back. So this makes this a soft work for us. You find the derivative of what? U. So this is what? Derivative of u. Abi, I'm trying to explain the formula for you. Over u itself. Now, let us solve. If we are to find the derivative of what? If we are to find the derivative of what? U. That will be what? It's like you trying to use chain formula, but I wouldn't really call it chain formula like that, in order to avoid confusion. So if you have to find the derivative of this, that is u1. U derivative, that will be what? 18 what? X squared plus what? 4x. So, since you have gotten this, then we can now safely see that our dy over dx is equals to what? 18x squared plus what? 4x over the whole of this, which is what? 6x cubed plus what? 2x squared. As soft as that. So now, if you have any question as regards this, you can ask in the comment section below. Now let me now solve the final one for today. Then we can call it a day, which is what? Y is equals to what? Inverse of what? X squared. Now, we all know offhand that this is our question, right? We all know that if y is equals to in x, then our dy over dx is equals to what? 1 over x, right? This is a what? Logarithmic function, right? So it applies to the method that applies to this also applies to this. So this is what I'm trying to say. You find the derivative of what? X, and that's what? 1, abi, over what? X itself. What we did here. So now let me explain it here. So we can say our dy over dx. This represents our u now, abi. So if you find our derivative of u, this will give us what? 2x. If you find the derivative of this, that will give us what? 2x over what? Over x squared itself, right? This is our answer, but something can go. You divide this here 1, you divide this here 1, and that will give us what? 2 over x. So this is our what? Dy over dx. It is as simple as that. So, like I said, I'm not here to take much of your time. It's just to explain this as easy as possible. So I have a general view of it, whether you might want to screenshot, then try attempting it yourself. So now this is where I'll be stopping for today. Thank you very much for staying with us up to this time. Kindly like and subscribe and share my video. See you in our next class. Thank you.